Hello, ladies and gentlemen. This is Weather Brains, episode number 632 for the 26th of February, 2018. It's the pre-show, and you know what this is. It's a magical time where we share boring personal stories, humorous anecdotes, and we say some stuff that's really outrageous. We've got 12 minutes to do that. So, Brian, you were not here last week. Please, sir, give us a report on where you were.
I was roaming the sands of Miramar Beach, Florida, in Bermuda shorts and black socks.
I knew it with a metal detector. That mental picture is just front of mind. There's Brian, Bermuda shorts, black socks, dress shoes, and a metal detector.
No dress shoes. I didn't wear my dress shoes out into the sand. That's gauche. That's terrible. And I didn't have I didn't have the metal detector. It was the guy behind me.
Oh, oh yeah. No, that's gonna happen to all of us one day. We're all gonna go down to that point, but hopefully we're not there yet. So let's see. We got Bill Murray back on the show with us. He was absent last week. Bill, was it?
Opening a hotel of all things. Fortunately, that's done now. But you left out one thing that we do during the pre-show, James.
What?
We frantically try to get the guests to connect on the show.
Yeah, well, that's it.
Oh, come on. You mean Greg can't do that?
Tap on your mic, Bill. Let's be sure you got the right mic on.
Yeah, I haven't switched it over yet. Hold on a second.
You sound like you're in a urinal in a bathroom stall at the New Orleans airport.
Yeah, that's where I am, actually.
Brian, ever been to a urinal in a bathroom at New Orleans airport?
I don't think so.
I think I have. I think I used the bathroom in there one time.
How does that sound?
That's better.
Is that better?
Yes.
I'm not sure I've actually ever been to the New Orleans airport.
Really?
Louis Armstrong Airport. Yeah, I was.
You haven't lived until you've reported from the toilet of an Amtrak train. That's going to beat the New Orleans airport any day.
The only train I've been on was one that was in 1987 or something. It was some Alabama thing, a sesquicentennial or something. And they had this train that went all through the state. And I hopped on that thing and went from Tuscaloosa. I think we wound up in Montgomery or somewhere. But that's my only train experience.
So we took the train from Birmingham to New Orleans for President's Day weekend. And by the time that train gets here from New York and it's about 7 hours late and people have peed all over the toilet, it can get rough.
And that's a show title.
Is that a show title? Yeah. I don't think I'm going to type that one in.
No, I don't know. I think I've done my train ride for my life.
Well, they just built this, multi-million-dollar train station in Birmingham. It's beautiful.
But the trains are still late, huh?
Yeah, but President Trump's going to cut out all the trains anyway, so it's not going to matter. So it'll probably be a nice Greyhound station before you know it.
So we've got Nate in San Francisco out. We have Rick Smith teaching Skywarn. He's out. We have Kim, who is dealing with students gone wild. She's out. But Aubrey's here.
I am here. Hello.
We're saved.
We are saved. If she's here, all is well.
My anxiety level always drops when Aubrey is here.
My husband does not say that when I get home.
Well, WeatherBrains compatriots and husband and wife, those are two different things, I think.
Radically different things. So now, does he stay up for you every night? Is he awake when you get home?
It depends on his work schedule. Like our side business that we have has been so busy lately, so he hasn't really been working his part-time job much. So sometimes, because he's probably still working down in the workshop right now, so sometimes he does. but he's kind of more of a morning person. So
it's just there.
I'd say my wife is up maybe 1 out of every 5 nights when I get home. I'll be in there and the TV's going. She's watching some ID Discovery.
Yep.
Or
Forensic
HGTV.
Files.
Yeah. And it'll just be blaring and she's just gone. She's just totally zonked out. So I think our guest is on here and there's nobody in the chair. But that's a good looking set. That is a really nice looking set. I feel so inadequate. I'm going to mute him for just a second.
Yeah, it says it's Pat.
That's interesting. Yeah. Y'all see? Oh, there we go. Yeah, there we go. Nice looking.
Hello, Pat. I'm seeing some satellite pictures and monitors, NASA logos. Yeah,
I'd be the winner for the best set we've ever had on the show.
I don't know that the space weather lady was pretty good.
The space people must just have good money.
Yeah.
Well, they have to. I mean, it's part of NASA. It's their thing.
You got to look good if you're in NASA, right?
Hey, Bill, your bandwidth's a little low. You got some kids running wild in there?
I'm trying to figure it out. Must have.
Like you're.
I'm trying to kill application real quick because
You are. Looks like you're on a 1200 watt modem.
I'm running on my 5G network.
Are you in some? Are you in a Hooters? Where are you tonight? Are you home?
No, I'm in the home office.
Don't you have some kind of fancy Wi-Fi, big pipes here?
Yeah, actually I do, and I'm on it. It's not as big as your giant fancy Wi-Fi pipe.
Gigabit fiber.
But that's only at his home.
Your bandwidth is extremely constrained for some reason. I think Bill's streaming Night Call Nurses or something, some bad videos or something there.
Show title.
Yeah. Streaming Night Call Nurses.
Aubrey, thanks for sending in your pick of the week. I always
welcome.
like it. You get it in so early.
I try.
I appreciate it.
I have no bandwidth whatsoever.
Efficient.
Yes, she is.
Otherwise, I forget.
The one who slays me is Kevin, though, because he'll send his in like the Tuesday after the Monday for next Monday. It's like, I'm not ready to do next week's WeatherBrains on Tuesday after the one we just finished.
It's like tornado warning lead time. Sometimes they can be a little too much.
Yeah, I hate it that we started the year out with a bang with at least 3 fatalities.
Yeah, that was not good.
You know, that whole thing started slowly. I mean, I was way off in my timing on that one. Well, not way off. I mean, several hours because it just didn't seem to get cranked up. A lot of flash flooding, though.
Yeah, I'm just glad it kind of missed us.
Yeah, me too.
I was not in the mood to come up here on a Saturday night and spend the night doing tornado coverage. Nighttime storms with
Charles said he stayed till 2.
Oh, did he? Okay.
Yeah.
He is a fine American. I stayed up pretty late, working social media, but it's a lot easier when you're home and you're sitting there in your cargo shorts and T-shirt. When you're up
you
here,
wear shorts? I don't wear any pants when I'm doing mine.
That's a show title right there, ladies and gentlemen. I don't wear any pants while I'm doing severe weather at home. That's a great show title.
It's too long.
That's a bad mental picture. I'll tell you this. I have been known to, I do a little segment on television on our Good Morning Alabama show from my house every morning at like 6:15.
Oh, 6:15.
Yeah, 6:15. And so I have been known on occasion to have only underwear on underneath the nice little shirt I'm wearing. And I have great fear that I'm going to stand up because I'm sitting down at a desk like this and I'm going to stand up, like this. And, there'll be some polka dot underwear or something going on there. I have a really bad feeling that's going to happen.
You're not the only one that's afraid of that.
Yeah. Have you carbon dated your underwear?
Yeah, I need to. That's my standard line. I've got underwear older than you, and I say that to everybody I meet, which is true. But I clearly need some new underwear.
I bought some new underwear while I was at the beach.
Brian, you went to the beach to buy underwear?
No, I didn't go to the beach to buy underwear. We just went to an outlet area, and they had underwear.
Brian went to the underwear store at the beach. Hello, let's go down to the underwear store and buy some fancy new underwear while I'm down here.
It was my wife's idea.
This makes me wonder whatever happened to the guy that wanted to do the pre-show shows. Collect all the pre-shows, because this is going to run him off in a big hurry.
Yeah. So much for the stuff here.
I guess we better clean it up. Our guest has shown up, and we don't want to run him off.
And he's super professional. Look at that setup back there. He's got like a cameraman and a mic guy.
But his name is not Pat.
No, Pat has the account, I guess. We're trying to get Bill's bandwidth back on here. And let's see.
How does it sound now, James?
It's better.
Yeah, we killed all the gaming systems in the house.
Oh, so some boneheads were sucking the bandwidth, huh?
Yeah, the two Xboxes, I think, were taking us down the river here. So, as the lady in my office that is prone to malaprops said recently, it all went to hell in a trash basket.
And that's a show title. No, you're good now. So there we go.
I thought that was a hand basket.
That's what it's supposed to be, but it's prone to malaprop.
We're going to need to unmute our guest. I muted that mic earlier, and I don't think I can unmute it myself.
Uh-oh.
Now it's unmuted. Now it's muted. Now it's unmuted.
Now it's muted.
But
we're off to a rip-roaring start here.
Greg isn't moving much. Are you sure he's alive in there?
Let me welcome our television audience.
Greg.
We apologize to our television audience for this, but welcome. It's 30 minutes after the hour. We're joined by our television crew watching on the local ABC affiliate here. And we're going to start the show in a second. This is the WeatherBrains pre-show. You know what this is. We do this every Monday night. So I think we're all here, Bill. Are we good to go? Is it Greg? So. Can you give us a mic check?
Yeah, this is Greg Mann from the lovely studio at Goddard Space Center.
That's not going to work.
Now, the mic that you're wearing is not the one that's coming through the Hangouts. You'll have to go up to the little gear up there and select the right audio source. We are hearing you from a distant microphone, and you're wearing a mic, so we should be able to hear you very well.
Where is that? Where's he looking here?
It's on top of the Hangout window. There's a little gear there. If you mouse over it,
You got to go on the window, right there. And the microphone. That's the. I think you want to go on that one.
Man, that's a good looking video coming out of there. You talk about some bandwidth. I bet you these guys make my little 1 gigabit fiber look like a pipsqueak. All right, let's try it again. Greg, give us a mic check. Now there's no audio. No audio. Once we get that audio restored, we'll get this sucker going here.
We've gone from bad to worse.
Yeah. Well, we've gone from a distant audio to zero audio.
Let's check the audio now. Am I any better?
Bingo.
Yes.
Wow.
Hey,
Yay.
Right between the goalposts.
We have a winner.
It's the same feeling you had when Gozar launched perfectly.
Absolutely. I was going to say, whatever muted me, my wife wants that technology.
The old mute button. All right, let's get these recorders going. We're going to get this thing going here. Because it's time. Here we go in 5, 4, 3, 2, 1. This is WeatherBrains episode number 632. It's the weekly show all about weather. This is for the 26th of February, 2018. Knocking on the door of meteorological spring, Brian Peters. Welcome back. You were absent last week. You were down at the beach, right?
Yes. Enjoying the beautiful white sand beaches of Northwest Florida around the Destin Miramar Beach area. It was gorgeous. I'm still in vacation mode.
And the highlight was buying underwear, right? You said you bought some new underwear?
That's the highlight.
Wow.
We're embarrassing, Kevin.
I have this mental picture of Brian down on the beach, in his black socks, Bermuda shorts, tank top, and dress shoes with a metal detector.
Straw hat.
Do I need to tell you that the lady that was helping me out helped me try them on?
Ooh.
Oh boy.
That's a different show.
WeatherBrains After Dark.
There's your show title.
There you go.
Wow. Kevin,
that's
I'm so
a winner,
sorry.
Aubrey.
Always.
Kevin, I apologize. For a man of your character to have to hear this, I'm sorry.
It's terrible. I'm speechless for a change.
Can I put that in my resume?
Can I bottle that up?
Yeah. Oh, wow.
So, Kev, welcome to the show. What you been up to in Wichita Falls?
We got nothing. It was, upper 60s today, and just a week ago we were battening down the hatches for an ice storm. So, welcome to Northwest Texas.
Yeah, we'll talk about that. We'll do the weather roundup here in just a bit. We got Rick Smith. Well, let me point out we got a few off tonight. Rick Smith is teaching a Skywarn class, and we have Kim Cloco dealing with some academic issues, and Nate Johnson is on a business trip to San Francisco, where he's going to leave his heart. But Aubrey Urbanowitz is here. Aubrey, it's always good to have you on the show.
Oh, it's always good to be here.
What's happening in so what's happening in Harrisonburg?
Oh, we've been spoiled with this nice weather lately, and it's getting back to at least closer to average. And man, I don't know. I'm not ready for it. I'm ready for spring. 21 days. 21 days.
But again, if you use the meteorological definition, it's later this week. That's right. So we're almost there. But Bill Murray, bring in our guests. Let's get going here. We got some important stuff to talk about.
Yeah, James, I had the pleasure of introducing tonight's guest, Weather Brain, at the NWA annual meeting in September in California. And he's with us tonight. He's the director of the Joint Polar Satellite System at NOAA. He formerly was the system program director of the GOES-R series. Prior to that, he was the director of the Office of Science and Technology at the National Weather Service. Greg Mant, welcome to Weather Brains.
Well, it's nice to be with all of you.
Well, I tell you what, you're in the finalists for the best set for any of our guest Weather Brains ever, and you're in good company because another space weather person was right there with you, Greg. So all the money must be in space, huh?
Hey, these toys are expensive, so we get some side benefits from it.
Well, it's outstanding to have you on the show tonight. Of course, we're going into National Weather Podcast Month here in March, and the inclination was to have the best guests you could have on the show. So we're starting early by getting you. We're really excited about having you here at the end of February. So thank you for being with us. So
is this sort of the Weather Brain sweep month or something?
Well,
sweeps. It's ratings. Yeah,
exactly. That's exactly right. So, I was standing in the Rooms to Go store in Hoover, Alabama, the night that the GOES-R satellite launched, and I had my iPhone watching the launch on NASA TV, and everybody, of course, thought because it was in November that I was watching some sort of football game, and of course, here in Alabama, we like our football. So, pretty soon I had a whole crowd of people around me. They came in expecting to watch football, and then pretty soon we explained to them that they were going to watch the most important weather satellite launch in our lifetime. And, I thought a lot of them would just walk away, but they were just as excited about it. It was like, a chant of "Go USA, Go USA" is going to break out there at any moment. So how did you feel when you saw that rocket lift off successfully that night?
Oh, when you work on these satellite programs, you spend literally years going through so much paperwork and building and working through all kinds of problems. One of our adages is you can't launch it until you've created enough paperwork to be equal to the weight of the launch. So you're good to go. So after so many years of working and working through all the problems, to watch that fire go off and to watch that get lifted up into outer space, there's no feeling like it. I know when I was talking to some of the folks at the launch, they wanted what to compare it to, and I said, I'm a father of 5, and it's almost like the birth of your next child. You know, someone else is doing all the work, and you're the expectant father, pacing, and then you watch for the big moment, and it happens, and there's just such an emotional rush to see all those pieces, and you know every problem that you've lived through with every component of that, and there's literally hundreds of thousands of them, and any one of them could go wrong. So you're just hoping that your engineers have made everything perfectly so that it will achieve what you designed it for. So when it all works, you just can't be more excited for that.
So when did the journey begin for GOES-R, for you and for the satellite, Greg?
Well, for GOES-R, the first concepts of it, because if you look back, the regular GOES series that have been flying, in fact, still are, were really byproducts of the 1970s. So the designs and the instruments are all built and formulated in those. And so they served this country for a good 30 years. People, when you're used to the technologies, you're getting certain capability. The scientists at the cutting edge know what could be done. And so they keep putting those ideas out there. So once you get these great ideas of those smart research scientists that says, hey, this is what we can do more. In the late 90s, we started to say, well, we could really do some amazing things with imagery. We can do a lot faster, a lot higher resolution. And we started to spec that. And in the late 90s, we started issuing some contracts with the various industry partners to look at what they thought they could do and how to build it. And then by the early 2000s, we actually put them on contract to start building the instruments. And then about 2008, they gave the contract to Lockheed to buy the satellite itself, the bus to carry the instruments. And so then 2016 is when all the pieces came together and we were able to launch it. So it is a very long process, and hence why it's so exciting when you actually watch it go up into outer space.
Now, you hopped right over to the JPSS program right after the GOES-R program was up and running. Talk about that transition for you. How did that happen?
Well, so I was, if you go back to the beginning of when I was brought into the GOES-R program, it was like 2007. The 2 guys previous to me were sort of relieved of command. These programs are so expensive and so complex. So many things go wrong that you have a lot of, the IG, the GAO, Congress, everybody and their brother is looking over your shoulder for everything that goes wrong. So it's not a career for the people who aren't real brave of heart. You really got to be able to stand some serious scrutiny. So they brought me in 2007, and I spent those 10 years to really get GOES-R going. And about 2 weeks before the launch, when I was really getting excited about it, my boss came along and said, we've got this other program that's, not going quite as well. So as soon as you get this launch, you're going over there to get us till that one launch. So it was sort of my moment with the GOES-R was really a culmination, and then I got to really work with the team over at JPSS to really bring that to closure and finish up some of the issues that they were working so we could get that one to launch. So I think I'm pretty unique to be able to run 2 major satellite programs and get launches within a year of each other. It's quite an exciting thing for myself.
So one is a geostationary satellite, Greg, and one is a polar orbiting satellite. Explain the differences and what the advantages of each are.
Sure. With the geostationary, that satellite is up over the equator at about 24,000 miles up. So it's orbiting the same rate as the Earth is spinning. Okay. So what it looks like is, for an observer on the Earth, it looks like that satellite is right over the top of you at all times. And the great thing about that is it's staring at the same point. So you can take pictures repeatedly, every 20 seconds, 30 seconds, every minute, and lay them together, and you get like a nice movie clip of the weather that's going on. So clearly meteorologists love that view of the world. However, it's mostly a visual product. It's great for seeing what's going on, but it's very difficult from that distance to get a really good quantified measure. So that's why we launched these polar orbiting satellites at a much lower altitude. Here you can see the graphic that just shows that as it flies over, and it's flying about 400 miles above the Earth. And the instruments then can measure the temperature and moisture fields from the satellite down to the surface of the Earth and really characterize what the atmosphere is like. That data then will go into the numerical weather models so that they can then produce the forecast with a lot of accuracy. So with that, the temperature and humidity from the satellites, you can really populate the models to allow for the forecast. In fact, about 85% of the data that goes into numerical weather forecasts are from these polar orbiting satellites.
Greg, you mentioned how long it takes to get all the pieces put together, all the planning. And this may sound like a weird question. I don't know if I'll ask it correctly, but if you look at the satellite as it goes up, it's on the launch pad, and the day it goes up, how old is some of that technology, and would you have liked to have been able to update it? Does that make sense? Something in there is 10 years old and something new has come out. Does that make sense as a question?
Well, it's a good question from the perspective of the technology that we see as consumers, like consumer electronics. That is evolving quite a bit. A lot of times in the space world, the technology just doesn't move on its own, right? And so programs have their need, like I need a detector that can work and measure this spectrum at this resolution. And so you sort of have to push somebody's pushing that technology for some application. So for us, it took those many years to really get the detectors and really work that out. It's a very expensive proposition to get the detectors mature enough of technology so that you can actually build them. So clearly now there will be advancements in chemical engineering that perhaps you can get a better detector, or over time, like electronics gets more efficient, so you can package it in smaller packages.
Mm-hmm.
So, for example, at this point, we can certainly probably make it a smaller package than we could 10, 15 years ago. But from the business end, the dramatic improvements in what you see, like with the GOES 16, and what we'll see with the next GOES launched here this Friday or this Thursday afternoon, is still a tremendous step up from what the forecaster is used to doing. Whenever we introduce these new technologies, it seems that it takes us quite a few years to really understand how to really apply and use all the data sets from these satellites, especially in the numerical models. We'll be tuning them and really exploiting these data sets and improving the use for years to come.
That's interesting about the development concept, though. I guess what I was thinking is, when it went up, you're not sitting there thinking, well, we're flying with an iPhone 4 and we really could have had an iPhone 10 because that's what's out now.
Right. It's so if you think of like GOES, the resolution of that is giving you such sharp pictures of the Earth. It is just when we were first looking at these images, we were using saying, hey, it's like going from black and white television to HD TV. It's just so much sharper and crisper, right? So, it's hard as a meteorologist to see the value of a dramatic improvement in resolution. However, it could be that additional spectral channels, you might be able to see different features. So I know that the research scientists always say, well, Greg, can we add a couple more channels? Because if we did that, we could really see the clouds and get better height assignments in the clouds. So there's always a spectral improvement that you could do that that scientists are interested. And so they're already inquiring about, hey, can we do this? I think some of the biggest advancement, though, are technologies with respect to things we can't measure. Because if you're thinking of the polar orbiting, we got the nice detailed temperature profiles. We've got humidity profiles. But as you know, in weather, the one thing you would really like to understand better is the wind field. If you could directly measure the changes in the wind field, you could really better predict the weather much better than trying to assume it from changes in the moisture fields and temperature fields. So to be able to come up with a sensor that could measure the wind fields directly is sort of the exciting edge of, okay, how do we get, they're proposing laser technology that can measure small particulates, that you can measure the wind fields and put that directly into models.
I'm sorry, go ahead.
But as you can imagine, trying to get a laser that will last for many, many years, that's shooting for lots of times, is a technological reach. So we've been trying to perfect that technology for years. But that's an example of, it's really a new sensor that can measure winds, for example. That is where we would really, really like to get things.
Can you see a light at the end of that tunnel? And is it 5 years off? Is it 50 years off?
It's been one of those things. It's been 10 years off for my 30-year career.
Right.
So it takes a lot of investment. So you got to build a case for it. Get investments, and that's where pushing the technology. NASA's done a lot in pushing technology, but we're going to continue to assess that and say, hey, when is it possible to fly it? They have demonstration missions where they flying it, but trying to get a sufficient long lifetime to make it worthwhile for the operational folks is probably where we are. So there new technologies to measure new things that we're not measuring is probably where the next advances we'd like to introduce are.
When you start testing that laser, I would suggest you point it at James's house for that period.
Bring it on. Bring it on.
Yeah. Hey,
are you saying he's got a good reflector there?
No, you said that. I didn't.
Okay. I was just trying to understand.
That's the show title. James has a good reflector. I have a two-parter, and I have a television show I have to go do, so I'll ask the two-parter and then hang up and listen later, as they say. You mentioned all the great new products in the high res. Where are the best places? I look at College of DuPage mostly to see new GOES stuff. Where are the best places to see all this stuff? And then, maybe more importantly, almost, where are the best places to find out how to use all this stuff?
Those are off the top of my head. I like going to, because a lot of this we put forth into the weather forecast offices, but that's not necessarily, we do things, to put it into the hands of the Weather Service guys. The blogs I like, there's a satellite liaison blog. We've got some researchers we've put out in a number of the National Weather Service centers, and they have a satellite liaison blog that they put they're looking sort of on the cutting edge in terms of taking the new data sets, applying them to various meteorological problems, and showing how it can be used. So they're a very good cutting edge. The University of Wisconsin has a very nice a website, as well as Colorado State, that shows how to really get it. The NASA Sport Office down in Huntsville, Alabama, they've got another good cutting edge how to use the data. Those are some applications. We also work with COMET and those same institutions to put together a lot of training material. So if you go to COMET and look at the METED, the METED website, there's a lot of training material that's been put together so that a forecaster could really learn how to use a lot of these tools. But again, the satellite liaison and that blog, they are sort of cutting edge, and every time they see a new feature, they'll talk about it and how to use it. So those are interesting places I like to go just to see what the researchers are coming up with.
So James, how are the television providers doing in your estimation of getting the GOES data into your hands?
It's not too bad. We use WSI, Weather Services International, which is the weather company. I lose track of who owns who. It's IBM, I think. That IBM owns the part that feeds our data, and they seem to have a pretty good data stream flow. But I'll be honest with you, if I need new high-resolution satellite data just for my own use and forecasting, I'll go straight to College of DuPage, which in my opinion has got one of the best web presentations of satellite, GOES 16 satellite data of anybody is fantastic. It's a lot easier than the WSI box we have. Brian, don't you agree? It's kind of
yes, oh, absolutely, yes, much easier.
Yeah, I mean, yep.
So muted for television purposes, or are you able to talk? I guess she's muted for television purposes. So Greg, what about SIFT? I heard that as a tool. Is that something that operational meteorologists can use to learn more about how to use it or how to access the data?
I didn't understand the term you used. The
SIFT, S-I-F-T. I saw that in my NWA notes from maybe Jordan or somebody as an option for.
I'm not. No, I'm sorry. I'm not
you're familiar with.
I'm not familiar with that tool.
Well,
you have to remember you're talking to an engineer, so.
Okay, yeah, that's true. So that is interesting. Talk about the roles that NASA and NOAA play together in this process. That's probably a good place to ask that question.
Yeah, for NOAA, obviously we have the mission, so we're asked by the nation to actually go do the operational satellites. Our competencies are heavily into the science, and my job in both GOES-R and now in JPSS has really been to bring the money and the program management tightly coupled with NASA, and NASA brings a lot of the technical expertise in all the disciplines of actually building this together and the processes by which you review and test and check this out. So NOAA and NASA has a tremendous partnership over many decades to bring these satellites to service. So because NOAA has the mission, we sort of establish the requirements, get the money from Congress, and then work closely with NASA as they do all the development and launch, build, and test out of the satellites. And then NOAA will operate them and provide the data.
So how does the future funding look in terms of how the government budgets are looking coming up in future years? Is there good support for these programs?
The nice thing is everybody loves weather satellites. It's a great business to be in. If you look at government, every administration that I've been involved in has really liked the accomplishments and what the weather satellites do for the nation. The fact that most every American looks at the data every day, I think, is an example of why there's such great support. The scrutiny is very hard. They want to make sure that the program is put together correctly. The funding, there's a lot of independent reviews to verify that the funding requests are actually what we need. And then there's close following as we execute it. And it requires a lot of communication with Congress and the administration to make sure everything is still on track. So with that kind of oversight and providing visibility into our success, our support has really been phenomenal through multiple administrations. We've had support on both administration and congressional sides. So you can execute these programs. They're very difficult to control. There's so many moving pieces, but when you got a steady flow of money that you don't have to worry about changing it because of the money, you can execute them a lot better. And so we've done quite well in these two programs of delivering to the promises on cost and schedule. So that's our true measure is delivering the technical capability on the cost and schedule you promised.
So Brian Peters, Greg mentioned that it was like going to HD television with GOES 16. What were we working with when you got into the Weather Service? What satellite was there, and what would that have been like?
Well, initially, didn't have much of anything because it was in the eras, where Tyros had just been basically proven to, was proving the concept of the satellite imagery. So that's when I first started. So,
and then by the time we were in the 70s and the ATS satellites.
I mean, it's all the satellite from, when you think about Tyros and then coming all the way to, GOES 16 or GOES-R, whatever you would call it. It's just absolutely phenomenal. And I think something else is phenomenal is, I used to have this data only when I was at the Weather Service office, and now I've got this data right here on my desk. So
yeah,
it's absolutely amazing.
I bet James Finn spent a few nights at the Weather Service scarfing some satellite pictures from J.B. Elliott that he could use on air in the late 70s.
No, people have no idea. But back in the in those days, to get and again, I guess some TV stations had the machines in the weather office. We did not, so I would have to drive to the local National Weather Service office and literally get a still photograph, drive it back to the TV station and shoot that thing on a camera, and they would chroma key us over that black and white image. And that's how we got current satellite imagery. The only other choice was to use these network loops, and they were just horrible. That they'd come down at 4 o'clock in the afternoon, and they were like hours and hours old, and they just looked bad. And so when we got that Apple IIe in a Chromemco back in 1982, and we got satellite imagery in digital form, I thought it will never, ever, ever be this good. Never. And I still say those were the good old days.
And now you can see ripples on top of clouds in 30-second increments. And
I'm curious, Greg, do you remember I'm trying to remember what it was called. It was called, I think it was the UPI satellite machine. Do you remember those? Yeah, I mean, you probably weren't in satellites that far back. That would have been, gosh, very late 70s, early 80s.
No, I was still in the airplane business. I was in the Air Force doing airplane research. So I was designing flight control systems for airplanes back then.
Well, that UPI machine was just, top notch, state of the art, but it still only produced these black and white images. And then we had the Fujita wheel where we'd tape these images down, and it, created on a circle, on this big circle. And you'd put it in motion, and it would go at a constant speed, and so you'd essentially be creating an animation. So
things have changed so much.
Isn't that the truth? Gosh, I feel so old.
So Greg, you mentioned the next GO satellite. What other instrumentation is going to be on there that's going to make us drool that we don't have now?
Well, actually, I mentioned about how it's a very significant cost to develop the first one of these. So the next 4 GOs are just identical. So the one that's being launched is identical to what we launched. The GOs R, GOs S, GOs T, GO U will all be the same. So in a sense, we're putting up a constellation that'll give us 20 years of coverage with the same capability. So hopefully, I like to tell meteorologists, you're lucky to be around at this point to watch this tremendous improvement come up in your career, because there's people who've gone through a whole career that never saw this. In fact, I've talked at some conferences where there's retirees, and they're like lamenting that they just retired because they wish they were a new kid out of grad school, being able to forecast with all these tools. It's a very, very exciting time to witness these new capabilities and be able to use them over the next couple decades.
Well, Greg, what is the lifetime of the one that we've just kind of become operational up there, GO 16? What is considered the operational lifetime of it in terms of its service?
We designed it for 10 years of life, but we put enough fuel on it to last almost double that. So we don't want it to get low on fuel, because it takes you have to burn fuel to hold it at that orbit. It sort of starts to wobble if you don't keep fine-tuning the orbit. So we've got a lot of fuel to do it. So it's a matter of how long. Typically, it's how long will the instruments last, like the imager. Will you end up? Space is a pretty rough environment with electrons, protons, whatever, flying through the air, and you get hit by those. So we build a lot of redundancy into things so you can survive a lot of that, put shielding on. But over time, that accumulates, radiation accumulates. So hopefully we did a good job of that, so we'll get a good 10 years out of each of these.
A little hard to send a space shuttle mission out to 24,000 miles, isn't it?
Well, there's a lot of interesting work done in robotics where people are, we put little targets on there, and the space robotic people says we could fly up there and refuel you. And actually, the commercial communication satellites are actually working and doing some of that, because, as you can imagine, the communication satellites, that the lifetime of them is going to really be limited just by the fuel. If you can replace a fuel, you still have the comm. For us, the detectors degrade over time and that. So, you don't want to keep refueling something as the instruments get bad. So, but
right.
There are systems that are starting to look at getting up even to geostationary and to refuel birds up at that altitude.
Wow, that's amazing.
It's an interesting technology. It's pretty expensive. You still, to get anything up to that altitude takes a whole lot of launch vehicle.
So has the next generation after this series of 4, is the next generation after that in the works? Or
yeah, there's a lot of work in terms of studies over what's the greatest need of the meteorological community, what is the do that, how would we do that? Mm-hmm. And people are thinking, we've got these 2 flagship programs, the JPSS and the GOES. So as I mentioned, it's new instruments in that might be the next thing. So a lot of what they're looking at is certainly how to keep these going even further out in time, but rather how can we do things like hosted payloads, get an instrument, but maybe go get a ride on another platform and test things out, or maybe small CubeSats and do other measurements through that technique. That's a little bit faster, a little bit less expensive to get new measurements. So we're looking at ways to complement these big ones, as well as how would you do the next generation. We are obviously always thinking about that. As I mentioned before, as electronics get smaller, can we do these smaller? Always exploring what is the next thing. But it's pretty hard when you're spending the kind of money we're doing on these 2 big ones to go ask Congress for a lot more, And the Weather Service guy says, Greg, you guys get all the money for those big satellites. Can you, we'd like a little bit of this in our operations too. So we're all this inside of NOAA, trying to figure out the right balance of funding for all of the desired activities are.
Well, that begs the question of how does the latest budget proposal impact any of the future satellites, or are they pretty well isolated and no problems?
Yeah, right. The administration and Congress, when the new administration came in, they asked for our plans, they looked at them, saw the support was solid, and give us every dollar we've asked for. So there's not been a problem from the satellite side. Congress has been very supportive, even through all the other chaos. Because there's nobody out there saying we shouldn't do this, right? Nobody's saying this is bad. This is
right.
Everybody's saying, hey, this is great for the country. This is a great benefit. We want to be there and do these wonderful programs for the nation. So it's the support's been great.
That's great. Thank you.
So one of the technologies that's been really interesting to me is the lightning mapper. How does it work, Greg?
Well, basically, it's fun to try to explain this to high schoolers, because you can sort of get the simplicity thing. But I basically describe it as the world's biggest camera. Only it's tuned to like 777 nanometers, which is where lightning is really peaks at that frequency. So it's got a single frequency, and it's snapping basically a snapshot at 5 milliseconds. Or so 200 times a second, it's getting that image, and it's just a simple detector taking an image 200 times a second, and then sending that back down. So the folks who've been, this is one of those things where NASA flew on the TRIM satellite, one in low Earth orbit, probably 30 years ago to test out the concept. And it took about 10 years to convince people that, we need to fly it operationally. And then it finally got manifested on the GOES-R where it developed. And the potential that it has is just phenomenal. The researchers are showing how the signal, the lightning intensity changes, that variation is a real signal to what is happening in these storm systems. And some of the researchers down at Huntsville correlated a jump in the lightning activity with the onset of early convection and the establishment of severe storms, where they were really pushing out the lead time. They did a whole season retrospectively of storms and found that they could double the lead times for all types of tornadoes. But even more amazingly, the signal had such high correlation that you could cut the false alarm rate in half. So if we can, really get that data set used and get it into the weather service operations that everybody knows how to use the data, I'm thinking there's a high potential of getting a lot better warnings with more precision and low false alarm that will really get Americans. My joke is every time there's a tornado warning put out where I live, what is it we do? We go run to the front door to see if we can see anything, right?
Of course.
It's not the behavior that people say we should have, but a lot of that is because of the false alarm rate. So if we can really drop the false alarm rate down with better correlation to the measurements with what's going to develop in the severe weather, the response of the citizen to that probably will be better than myself.
Can I get an amen out of you there, Brother Span?
Amen, brother. Hey, I wanted to. Hey, Greg, let's talk a minute, if you don't mind, about this spectrum issue where there's going to be some spectrum reallocation, and there was going to be potential interference to weather satellites with this company out of Virginia. What's the status on that? I've not heard of that news on that lately.
Well, in my career, this has been a continuous activity. Is that there's always so much bandwidth, right? And we use a number of them for both sensing and communicating. One of the big things we had to do for both the polar and the geo is in the S band, where we're communicating the direct broadcast out. That's a band that is of great interest to the terrestrial cell phone users, right? When they start going 4G and 5G, they need more ever increased bandwidth. And we're sort of a small user out in that space. And so they're trying to move into our bandwidth because there's not a lot of people using it. And as we all know from carrying our cell phones around, the demand for more and more data through those things is there. So the administration over the last 10 years is selling the spectrum off to people, and companies are coming in and competing for that, really to drive that market. And it's a challenge for us because we're sort of small fry in the world. So we try to get the word out to all meteorology users. Says, hey, if you want real-time access to this, we got to defend this and show the impact. So we've had to work with the meteorology management communities and users all over to try to keep an awareness that there's always a threat out there of losing the spectrum. And I'm not sure that any of us feel like it's just a holding thing. You can only hold things off for so long. And so with this new generation of satellites, we're trying to hold that off for a while so that we can at least get through this. But we'll have to continually look for different ways to communicate to the ground and deal with these. Because we can see it in the data where you get a lot of interference, especially around like our downlink sites. And we've tried to put protection out there, but it's certainly a challenge for us. And so for the next generation satellites, we'll continue to have to evolve with what the demands for these communication systems really will.
What can we do now just to kind of let somebody in Washington know that this might be a problem? Just talk to your senator. What's the best thing to do?
What happens is whenever there's the frequency is sort of allocated, you have to file. So, we've done all that. It says, hey, I need these, and I'm the one who gets to use it. So you file both nationally and internationally. And so you sort of protect that. But whenever somebody else comes in, they've got to file for that frequency. And so they will say, like, well, there's some frequency. Can I share it with the weather satellites? And so the frequency community will then put out notices to the community that say, hey, does anybody care if this company does this and shares with the weather satellite? It's at that point in time that we sort of like send notices out ourselves to the community. Says, hey, they're asking for comments. So here, please get your word in. So in a sense, we do try to use AMS and other forum to let people know when decisions are up for debate and to be able to weigh in. So we try to keep people aware of when those events come up.
Yeah, there's been tremendous advocacy on the part of the National Weather Association and the AMS in that regard. And that's very important. So what sort of, that interference would manifest itself how? Would we lose data, imagery?
Yeah, there's a couple times. Some of the frequencies would actually if you think of, I mentioned that on the polar orbiting satellite, for example, there's a number of microwave sensors to measure temperature and humidity profiles. And so you'll get an interference in one of those bands. And so it will just start to put a lot of noise on that channel, and we won't be able to discern the signal very well. Also on our downlink, especially the direct broadcast, so there's a lot of users who get the data directly, like you mentioned WSI. WSI will have a downlink antenna and get that directly from the satellites to make it available fast. Well, that's an area where if somebody could put a microwave antenna up right next, if you put it close to that downlink, there's potential interference. So we try to understand where that conflict could be, know where the users have those antennas, and try to keep that away. So it affects both the communication of it and some of the channels of measurement that we're trying to do.
You got that fancy set there, and we don't want to keep you too long tonight. We'd keep you till 11 o'clock if we could. Greg, when do you turn into a pumpkin before we go any further?
You're already past my bedtime, so I don't know. I told my wife that I had to work late, but she didn't quite understand that. So maybe I have to tell her where to go see this so that she can believe me.
Yeah, tell her to go to live.bigbrainsmedia.com, and we can corroborate that you were here. That's
excellent. That's good.
You've got a good alibi here, Greg.
That's right. There's a timestamp on there, right?
Yeah. We're not like Colbert. We're not recording this on Thursday night the week before. So Greg, I think we've all been drooling over a lot of the data and the different channels and things like that. Have there been any real big surprises from the meteorological community some things they didn't expect the data to do for them?
I think the words I've heard back is how many people have never seen this before, right? As they look at the data and they'll look at, gravity waves coming over the Rocky Mountains and its impact on the slope, and they'll see very high resolution, that translates to turbulence, the FAA. Amazingly, the FAA has been very excited about just the fog product and the resolution of fog and how they can really improve air operations. We don't have sensitivity to that, but, they have really improved minutes, both preparing for, the fog onset and dissipation, where they can really fine-tune their operations for that. And every day it seemed like someone's got another idea. Just this summer, we were showing the Weather Service how all the fires up in Oregon, and you saw the huge clouds coming over a lot of the West. And so we said, well, we've got these cloud products. We can see this stuff. And they says, well, how do you forecast that? And so we actually coupled these images of the smoke into the rapid update models and the smoke models, and the Weather Service is just incredibly excited about actually making good forecasts of those smoke clouds and where they are and how that's going on. Similarly with volcanic ash, we've got an incredible ability to really measure the ash content, the ash height, and really understand where that ash cloud is and to predict the aviation of where it's going to be. Tremendous science has gone in to really give this. So there are so many cool little applications where people saying, wow, I can really use this much better than I ever was able to do before. So as those keep unfolding, it's sort of exciting that, we build these things by dreaming it up, like I said, 20 years ago, but nobody is thinking of these kind of applications 20 years ago. You're sort of getting the basics, but now that the data is out there, people are finding all kinds of new ways to really get it to apply and learn how to use it even better in operations. I always joke that one of my real goals on GOES-R was to break through the radar mafia out there in Norman, Oklahoma. And I remember when we first were showing test data sets out at the spring experiment. And the first year we put all this fancy stuff out there. Again, this is years before we launched. And says, here's what's possible. And they looked at it like, yeah, you technologists are always showing us stuff. And it was like they sort of blew it off. And we kept going back and listening. And after about 3 years of showing them and then tweaking based on the feedback, they started saying, wow, this is really cool. Can we get this in my office now? So it took a number of years to get me excited, but I actually got the Norman crowd says, you know what? Both radar and satellites are good for severe weather. So I consider that a major success in the working with them and getting GOES-R used in the community.
Well, heck, now you got them where the Weather Service is calling the fire department in these communities and telling them there's a fire somewhere before the fire department even knows about it.
Yeah, that's awesome. Yes, we're there for everybody.
That's pretty cool. So I never really understood SUMI NPP and JPSS and how those relate. The SUMI is the predecessor for the JPSS, right, Greg?
Yeah, you have to, if you go way back in time, NASA was flying the Earth Observing System, which today is Aqua and Terra, or the remnants of it. But when that was first put together to really assess climate change, NASA was trying to get a 30-year history of the atmosphere of the Earth and high resolution to understand how it's changing, right? However, they flew one generation, the Aqua Terra, but they really couldn't sustain the funding to build 2 more of each to get to 30 years. So at the time, the NOAA and the DoD were trying to put together the follow-on operational satellite, and they decided that that would be the continuation of NASA's Earth Observing System in terms of continuing those high-resolution measurements of the atmosphere. However, problems in the NPOS program delayed that, and NASA couldn't get the money to get a second generation. So they put the SUMI NPP platform together sort of as a gap between the first Aqua and Terra to get the same temperature, humidity, and imagery data, as well as their radiation, Earth radiation, the radiation budget from Ceres, to put that on there so that you could get these long-term continuous data sets. So NOAA asked NASA to move that to the afternoon because we knew JPSS, after the problems of the NPOS caused the cancellation of that program, we knew that we were going to have a big gap before we get JPSS-1 up. So they moved NPP to the afternoon. So we were able to put the same instruments on and make sure we had that and provide some continuity through the time for the climate scientists to really have the long data sets on this. So it is all together now. And again, it's a sign of NOAA and NASA working together to meet the various needs of the agencies.
So I've heard a comment attributed to Louis Uccellini that there are no crappy models. There's only crappy data assimilation. So you mentioned earlier that the JPSS satellite is going to be really important in that regard.
Yes.
Talk about some of the new and unique data that'll be coming into the models because of it.
Well, primarily it's these high resolution vertical profiles of the temperature and humidity. I know behind me here, this is one of my favorite ones. This is the microwave sounder imagery. So this is basically the temperature fields up at 700 millibars. And if you can imagine that, this is the data that goes into the models. So you can see the temperature profiles. This happens to capture when, the Alberta, Canada was warmer than Indiana this day. And you can see very clearly in this, in the graphically in the data from that instrument. And then that goes into the models. And so the better you can get the resolution and tracking that, the better then the models can run that forward to get the future weather. Now, what we've really tried to work with the Weather Service, with the NCEP, it's really in the data assimilation, because the data assimilation is so complex and there's so many variables in there. You really have to work hard to get the forward transfer models, the radiative transfer models, and all that to translate the satellite measurements into the model space. And how well you do that is really critical to get good forecasts. So we've worked with the Weather Service trying to get the better data assimilation. We helped them actually push into use variational techniques to get the data in off synoptic times. So there's been a lot of advancements that we've collaborated with to do that. When I took over JPSS, I went over to NCEP and I said, how can I help you do better assimilation? So I hired about 3 postdocs for them this last year, I'd say for 3 years, so that they could fine tune them on various problems that they could do. And again, that's one of the things as being sort of the daddy warbucks of satellites. I've been very aggressive trying to help the Weather Service out in terms of pushing the science as it applies to them to get better utilization. And the modeling area is a big one to try to get increased satellite use in that. We've done studies and shown that about 65% of the improvements that the weather forecast models have been made are due to these improvements in the polar weather satellite. So it is a pretty significant improvements that we've done historically and really with this generation of satellites.
Well, James, it's Oscar week, and I nominate Greg and his team for the best use of screen share in a Google Hangout.
No, man, this is like awesome. I mean, I wish I had B-roll as good as these guys. Wow. Hey, Greg, let me ask one question. You know, everybody obviously is interested in SpaceX and privatization. Do you see that being an issue with satellites, maybe, where ultimately the government gets out of the business and the private sector takes over?
Well, I've been doing satellites since the mid 80s. And one of the challenges is people are so risk adverse, and it's worse than the government, right? No one wants to be accountable for you don't want to lose $1 billion satellite, right? Nobody. And so you will come up with another test, another thing to make sure nothing's wrong. Well, if you think of, since the 1960s and now, every engineer who's ever experienced a problem has come up with a test, how to test to not do that. Well, when you're testing everything with that much, it takes you so long to test everything and that it gets really, really expensive. So what's interesting about SpaceX is he sort of cut to the chase and just says, you know what, I'm going to do the job, let it happen. And he's found very creative ways to sort of drive out some of the unnecessary risk adverse activities that the government has imposed and come up with ways to do that. So it's a little bit riskier, but you have to find that fine line of risk and cost and how much risk can you take to keep the cost down. And I think what we've seen in some of their launch vehicles is they've really found ways to get cost-effective systems. And it certainly has pushed the traditional launch vehicle industry to find ways to really cut their costs. And so we're seeing that on the launch vehicles that we're using. And it could be that we'll be gravitating to the more commercial launch vehicles because they have found sort of that right balance on cost and risk. So it to me, it's a potential for a cost savings because the cost of getting to space is quite significant. So anything we do to reduce the ride is a good thing.
Awesome. And one more question. I know it's getting late. We wake up in the morning and just expect the data to be flowing. We expect it to be there from the geosynchronous satellites, the polar orbiting satellites. What's the biggest risk? Is it solar activity? What could go wrong? Asteroid, meteor? What can happen that would knock something out up there?
Let's see, on the satellite side, our friend the sun is quite a nasty beast if you think about it. When you see the solar flares, I know the imagery there of the SUVI. When you really look at the surface of the sun and what's exploding out of that, most of them are going left and right. If you got a major coronal mass ejection right at us, what that plasma can do, is quite significant. And intense levels of radiation and what that we've seen that cause dropouts. It causes upsets in the data. Hopefully we've got enough protection in terms of radiation protection, and we've got chips that are designed and the redundancy that we can handle that. But when you get some of these severe storms that hit us, the magnetosphere is a nice shield around Earth that protects us from all that. But when you're out there at a geostationary satellite, you're a bit exposed to that, and that is a bit of a risk, and it's a huge factor in our design to be able to deal with that.
But to me, the reliability is just stunning because you can't just go up there with a wrench and fix something. It just always works. So in this, it doesn't happen overnight. This takes years and years and years of preparation
and testing. I know when we laid out for the GOES-R test campaign, once you assemble it all, you're supposed to then test everything to make sure everything worked as designed. And when we laid out our test program, we said, it should take us about 2 years of normal work, right? Meaning, 8-hour days, 5 days a week. In actuality, it took us about 3 years of almost 24/7 work. So what it took to actually test it was much more than what we thought it would. And it was primarily because of all the communication systems we had on board. When we started adding up all the different frequencies we were talking and all the cross tracks, I know when we went into the first test, we said, okay, comm guys, go test your stuff. How long is it going to take? And he says, a couple weeks, so a couple weeks go by. He says, are you done yet? And he goes, oh man, no, we still got a bit to go. And after a month, we go, you done yet? Oh no, we're not even halfway, And after about 2 months, we go, guys, we don't got time for you to sit there and spend, because we got to run these tests like every few months, right? He says, we'll be testing permanently. And so he had to cut down a lot of the testing. So the testing of these complex systems is really a tremendous amount of effort to make sure everything works as designed. And so trying to do that very efficiently is one of the challenges on these programs.
Awesome. But it is, and for us practitioners down here on the lowest level, just a big thank you. It's stunning.
Amen.
It is in use every day, and we learn something every day from the data we're seeing from GOES-R, GOES 16, or GOES. What is it now? GOES East. What do you call this thing now? I guess it's
the nomenclature. Usually, we use letters when we're building it, so that's where the RSTU is sort of like the sequence you build it, and then you launch it and change it numerically. So became GOES 16. All right. So we have 2 operational slots. We call them GOES East and GOES West. So if we move GOES 16 over to GOES East, GOES 16 is in a GOES East slot. So that's sort of the nomenclature. So so on our computers, we still call them 16 and we'll call the new one 17. Sometimes the build order gets, you launch them not in the order you build them. So you don't want to use the same numbers. Otherwise you'd be launching 17 before 16 sometimes. So you switch from letters to numbers so that on orbit, it's done numerically. That's basically it.
Awesome. Well, we have learned a lot, Greg. Thanks so much for your time, and thanks to your director. This has got to be the coolest stuff. Like you start talking about something and the video rolls. I mean, whoever that is, this guy's good.
No, they're really good. They're fabulous. I was supposed to tell them what to do, and I told them I don't know if I could think and point them, so they magically did it all on their own.
Awesome. So again, if anybody would like to learn more, and I know we talked about this earlier, just one link or maybe a social media account. What's a way that people could learn more about the satellite program, the one that you're involved with now, the polar orbiting satellite program?
So if you just go to the NOAA satellite, the NOAA webpage, their Twitter, you got the @NOAA satellites, but we have Facebook pages for both JPS and GOES-R. We've got a YouTube link with NOAA satellites. So if you just go to the YouTube NOAA satellites, you've got amazing, that's where all of our B-roll is. So you can see all kinds of phenomenal videos there. There's so much out there anymore that that's where I like to point to is basically those sites.
Awesome. Well, Greg, thanks so much for taking the time to be on the show tonight. It's been a great show. The hour has flown by, but thank you so much for your work and what you've done for the meteorological community, and we look forward to great days ahead.
Yeah, thank you. Thank you for making it so easy. Us introverted engineers, this is scary stuff, so you made it real easy.
Okay. Awesome. Greg, thanks a lot. Have a great week.
Thanks, Greg.
You too.
Thanks, Greg.
Yep, bye-bye.
Okay, we are going to take a break for Professor Peters, and we got Tony Rice in the Astronomy Report. We're going to come back with Weather Roundup, the email inbox, the picks of the week, and much more as WeatherBrains rolls along.
WeatherBrains 101 with Professor Peters.
On the large synoptic scale, meteorologists deal with air that originates in a variety of locations. An air mass consists of a vast quantity of air that possesses common characteristics of temperature and moisture content. Air masses can form in either hot or cold regions, over large land masses, or over water bodies. These will exhibit features of the area of origin. For instance, an air mass born over the Caribbean Sea would likely be warm and moist. Air masses migrate throughout the planet, bringing with them weather conditions characteristic of conditions from their source region. Classification of air masses does vary across our science, depending on just which source material you happen to be using. Meteorologists generally classify air masses into 5 main categories on the basis of temperature and humidity of the source regions from which they come. These 5 basic classifications to be discussed here include maritime tropical, maritime polar, continental tropical, continental polar, and Arctic or continental Arctic. In this series of 101, we'll be looking at the broad characteristics associated with each type. Often these names are shortened to a 2-letter combination. The maritime and continental designations are symbolized with a lowercase m and c, while polar, Arctic, and tropical are symbolized by uppercase P, A, and T. So, for example, maritime tropical is shortened to lowercase m and uppercase T. In our next episode, we'll take a look at the maritime tropical air mass, which often affects much of the eastern United States. If you have a question about the weather, drop an email to question@weatherbrains.com.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
Yesterday afternoon, February 25th, an asteroid labeled 2018 DU passed inside the orbit of the moon, coming within 177,000 miles of Earth. It was discovered the previous Friday. You probably didn't hear much about it, though, and that's okay. This happens pretty regularly. In fact, 2018 DU is the 17th asteroid to pass Earth within a lunar distance this year, and the 8th this month alone. NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory in Pasadena, California, tracks objects like this one. Their criteria is pretty conservative, too. The database is filled with asteroids and comets, all that come within 1.3 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, and 1.3 of them works out to more than 121 million miles. However, the ones that are cause for concern make the potentially hazardous object list. PHOs cross Earth's orbit within 0.5 AU, but they also must be of sufficient size, about the size of your local high school's football stadium, to pose a threat. And that's not 2018 DU. We can sleep tight for now. Currently, the greatest risk in that database comes from an asteroid discovered back in 2009, and it only has a 5% chance of impact, and that's somewhere after 2095. Elsewhere in the sky, look for the night's brightest star, Sirius, beginning after evening twilight in the south. If you've got a pair of binoculars, look just 4 degrees below for the star cluster M41. That's your Astronomy Outlook. Follow me in RTP Hokie for more spacey stuff like this.
I see that Aubrey is back, so just maybe we have an email or two this week.
Letters. We get letters. We get stacks and stacks of letters.
Yeah, we've got some really good emails. So we will start with wrong one. Okay. From Michael Harper from Grapevine, Texas. Found us through searching for things on Hurricane Harvey and been listening ever since. I'd like to know more about how to read radar. And Kevin graciously sent some links on radar. And Michael definitely uses RadarScope, which is a favorite. So thank you for finding us and thank you for sending in our listener survey. We appreciate that. Now, here's an interesting one. This one comes from John Wilkinson, The Hurricane Heist, a movie trailer. And I just watched the movie trailer. Yeah, so its basic premise
tell us about it. Give us a review.
It looks to be, the premise looks to be a heist, like a big heist, like, I don't know, stealing a bunch of money and stuff in the middle of a hurricane. But I want you to see what they, can you see that?
Mm-hmm.
Yes.
This is part of the, I'll turn the sound down, but I want you to see how they have this. What I'm assuming is the eye of the hurricane, which is getting ready to attack.
What a great idea.
right there.
Oh, how funny.
And it comes out on March 9th. And it looks like they have based a character loosely off of Reed Timmer just by watching the actions and the car that looks very similar to the Dominator. So we'll see. That's probably going to be another, what's it? Sharknado.
Yeah.
Sharknado.
Is there?
But it had a successful hashtag.
Is there a character outside of a hotel stealing Wi-Fi that might look like Colonel Sanders?
Yeah, that looks like Colonel Sanders. Yes.
Steve the Jazz Man sent us in an email. Ben Pringle has been at Cake TV in Wichita here for 24 years and a meteorologist for almost 40. He has decided to retire. James, look at that. Someone retiring after so many years.
You can't retire. Come on.
I didn't know that was an option.
That's what I was saying. He might make an interesting guest discussing the changes in how weather is broadcast. Could be really cool. And this one just in, fresh off the press from Jay Farlow. I saw this article and thought of you guys because I remembered our Estonian friend Tarmo suggested a few weeks ago that progressive web app technology could enable NWS to have an app without really having an app. And of course, Tarmo being the brilliant Estonian he is, it was a very technical discussion. And apparently there's an article that kind of breaks it down for you. Which is very interesting. So that is what I have for the email. So if you have an email, send it to us. Email at weatherbrains.com. Love to hear your guest suggestions with some contact info, what you like, what you don't like about the show, maybe a cool topic that you want to talk about or hear us talk about, and maybe a cool rant for Kevin. Yes. Send us an email at weatherbrains.com. We're on the Facebook and the Twitter also.
All right. Well, let's just see if we can do a weather break.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is foreseen. When colors blink by night or day, precipitation's on the way.
But Kevin, you had some ice last week?
We did. We had quite a good soaking. We were running quite a bit behind on our average rainfall since the beginning of the year, but total ice, liquid equivalent ice and rain included from Tuesday to Saturday was 2.66, which put us 0.11 inches above average so far in the year. So that was most welcome. A good half of our DMA is under the extreme, not the exceptional, but was under the extreme drought category. So this obviously will help that. We'll see what the new drought monitor has to say when it comes out on Thursday. But yeah, ice is never fun. Fortunately, we had some, we got more sleet than freezing rain, which is kind of always better for not knocking things down and driving on and stuff like that. But you get a good ice storm like that, and then when it melts, boy, that's a good gentle soak as opposed to summertime thunderstorms. A lot of that moisture just runs off.
Awesome. And also, since our last show, we had the first tornado deaths. And I want to say the streak was, 283 days with no tornado deaths across the country. Right. And that streak ended. That was a record length of time with no tornado deaths. We had deaths in southern Kentucky, and I think we had one in northeast Arkansas. And Brian, down here where we are down here in the deep south, that was a little north of us. We kind of just had a lot of rain.
By the way, SPC is only listing the 2 in Kentucky right now, James, on their.
Okay.
They did have. No, you were absolutely right. They did have 3, but I was looking at their. They put out a message. I can't remember what it's called, but it has to do with the statistics on all this, and they're only listing 2 in that particular product. So. Maybe they don't have all the confirmation they need on that 3rd one yet.
And it maybe, I don't know if anybody knows the circumstance on the southern Kentucky tornado. I want to say it was Logan County. Does anybody know if the warning was timely? I don't know how the warning process worked with that one. It seemed like that was way ahead out of the main batch. Does anybody know if the warning was good?
Nope, I don't.
Well, we'll investigate that. But again, it was a severe weather type flooding situation. How'd you do up there in Virginia, Aubrey, with this batch? Have a lot of rain?
Yeah, we had some rain. That was kind of it. So, but yeah, we had a fair amount of rain, which is good for us because we've kind of been in a drought since November. So this is the first time we've actually seen above average rainfall since October. We're still down a couple inches, but we're kind of in the abnormally dry, what I consider the minor drought category. So definitely not as bad as a lot of other areas. But since we're kind of almost in a rain shadow here, if we don't get enough moisture, especially in winter, then it can be tough, heading into spring and summer if we don't get a lot in the spring.
Yeah, and looking ahead down the line in a few days, looks like might have a big northeastern storm. Your buddies up the road will have to keep an eye on that thing. Boston,
yeah, I was looking
and Long
at some
Island.
of the wind gusts. The wind gusts progged for us. I mean, we could be talking sustained winds, closer to 40 miles an hour at times.
Yep, that'll be late this week. And also a chance of more strong storms at midweek on Wednesday from roughly Dallas up to Memphis and Tupelo. So busy times, but let's do picks of the week here. Let's go around and everybody share something that they want to select. This can be a website, hardware, books, anything. So let's do picks of the week. Let's start with Kevin Sellis or Selly. Who used to call you that? Who called you Sellis? Was it Leo Laporte?
Yeah, that was Leo.
Yeah. Okay.
Yep, that was it. As is often the case when I don't have a pick at the last minute, I will go to boston.com/big picture. But there were really good ones there. They have some, they're all black and white, but there's quite a number of really good pictures from the Boston area from 40 years ago. It is the 40th anniversary of the blizzard of 78, which hit there. I was living in Philadelphia as a kid at the time and remember quite a bit of snow from that in Philly, but quite a bit of damage and some really good old pictures on boston.com.
Wow. That was a big one. A lot of the old timers still talk about that. So cool. We'll check. And all these links will be up on the website, weatherbrains.com. Brian, what's your pick of the week?
Well, I had planned to use Hurricane Heist. I just think it's kind of cool to have weather as the topic or the background, if you will, to a movie. So that was my plan. I'm still looking for that scene where I'm stealing the Wi-Fi, though.
It's there.
Colonel Sanders Thief, played by Brian Peters. Yes.
Bermuda shorts and the Black Sox.
Aubrey, what you got for us this week?
Mine is a Twitter from Storm Hour. It's at Storm Hour. They tweet and retweet a lot of amazing pictures, and they also have kind of a link to a site where you could be the picture of the week, basically. So James is always touting that I, push out some great pictures on Twitter, and almost all are not mine.
You suppose they'd use me in the Bermuda shorts and Black Sox?
They could. Did you see the paparazzi when you were down there?
No.
They might have been hiding.
Hey, here's the blurb on Hurricane Heist. The rural town of New Hope, Alabama, has a pair of supersized problems heading its way. There's a hurricane bearing down on the Gulf coastline, and there's a team of 30 well-armed mercenaries intent on looting the local treasury facility. So there you go,
brother.
Well,
wow.
New Hope, Alabama is in Madison County. Near Huntsville. That's
to
going to be kind of hard to pull off.
There is actually a New Hope, Alabama at the northern end of the state.
I thought so, yeah.
Yeah.
As far from the Gulf Coast as you can get. So,
well, apparently this hurricane's powerful enough to have moved it to the coast.
Wow.
All right. Well, to it, maybe.
My pick, it's the College of DuPage Goes site, which is just fantastic. I spoke up there last year, and they do a great job. And let me do a quick SPF here, a selfish personal plug, or an SPP. Yeah, SPP. This SPF is selfish personal forecast. They do that on the Rick and Bubba show, the syndicated show I do. This is an SPP. I will be every year in the spring. I typically will be speaking at one weather event, and this spring it's going to be the Central Indiana Severe Weather Symposium. This is in Indianapolis on Saturday, March the 17th. And looking forward to that. Some of the other speakers include our own Kim Cloco, who is going to be there. Brian Smith of SPC. We've got Dr. Dave Call of Ball State University. Dr. Dan Dawson of Purdue University. We got, let's see, Jay Farlow. It looks like he's going to speak. He just sent us that email. Jay is involved in ham radio, and I met Jay last year. Mike Ryan, lead forecaster at the Weather Service, one of the lead forecasters at the Weather Service in Indianapolis, and it should be a whole lot of fun. So if you are a WeatherBrains weenie, weather weenie in Indiana or some of the adjacent states, come see us. And again, that is going to be on Saturday, March the 17th. And I also am going to be.
What is your talk?
Well,
I haven't decided yet. I'll decide the night before I go. So you know me.
Now the following weekend is the Southeast Severe Storms Symposium at Mississippi State, where Rick Smith will be one of the speakers, the keynote speakers. And I will be there, and Brian and James are going to come and drive up and visit.
You know, if you're plugging stuff, then I should mention too, I can't go. I wanted to, but this coming Saturday, March 3rd, all day from 9 to 5 in Colleyville at the Colleyville Center is the annual Tessa. Yeah, that's always a good one. I've gone a number of years. I can't do it this time, but that is March 3rd, Saturday, and you can get information on that at Tessa, TESSA.org.
Yeah, there's so many good things that go on this time of the year. Tessa is great, and the Starkville event is really good. Brian, we have to figure out a way to get over there.
Yeah. James, I think you should recreate the year you tried to kill me in the van, me and JB, right there outside Tuscaloosa.
I'm going to need to try some of this good barbecue down there.
Oh yeah, no. What you want to do? What we need to do if we get over there, we're going to drive about 20 miles down the road to this place called Ackerman, Mississippi, and we're going to go to this establishment called Pap's Place.
Yes.
And that might be the greatest home cooking buffet in the universe. And
that's
Brian
will came up with the CPAP machine after all the people who got sleep apnea from gaining 100 pounds after eating there regularly.
And Brian will be putting on the big catfish head they have there. But no, the Starkville event is great. And also, while we're plugging things, one more, I'll be speaking at the University of Georgia on March 22nd at the AMS chapter meeting. And I've had the pleasure of being there before, and we'll see our friend Dr. Shepard and all kind of folks. So if you are in Indiana or Georgia, there's your chance to hear me carry on, and got some new stuff to talk about there. My mind runs so fast, I could talk about so many things, but I will figure it out by the time we get there.
Where's your book? You've got all these things. Where's your book?
Sorry.
You said you were doing a book.
I've been writing a book for years, and it is probably 75% done. But the problem when you're working between 4 a.m. and midnight and you need to sleep, a little bit in the middle, it's a little hard. But I tend to write when I'm like at Christmas, when I'm on vacation, and some in the summer when it slows down a little bit. I'll get there. I mean, this is going to be a very interesting read. It's going to be a tell-all book about the people in my office, including Brian Peters.
Wow. Wow. I'll be first in line to get a copy.
You don't really do anything on this show. Maybe you could write on Monday nights too.
Wait a minute. That's
boom.
No, you're right. That's a great idea. I could spend the 90 minutes here and write. But speaking of 90 minutes, I'm looking up at the clock on the wall. Bill, what's your pick of the week? We got to go here.
Well, I was going to use the SIFT, the Satellite Information Familiarization Tool from Wisconsin's SSEC, but when Greg had never heard of it,
he had no idea what you were talking about. None.
I think it's a good site.
I do too. And so anyway, I switched to my complimentary roll of paper towels that President Trump threw out in Puerto Rico after Hurricane Maria, after I spilt an entire cup of coffee right before I tossed it to you, James. That's why I disappeared, because I knocked an entire cup of coffee off on the floor here. So thanks for grabbing the end of the show there with Greg. That was great. As I mentioned earlier, this is March is National Weather Podcast Month. And we'll have a little roundtable next Monday night, March the 5th, with the state of the weather podcasting industry with a bunch of the giants from the 9 weather podcasts that are out there now. We'll have all the legends of chasing on Monday, March 12th, We'll have people like Tim Marshall and Greg, Jeff Piotrowski. A bunch of folks will be joining us that night. I'm going to hand it over to y'all on the first night of spring break for Monday, March 19th, and it will be Chuck Doswell Unplugged.
Wow.
So an entire show of Chuck Doswell.
Wow. Where we're going to have to get the censor on the television side to hit these. Yeah.
That could come in handy. And then meteorologist Cindy Day will join us on the final show of the month on Monday, March 26th, to talk about a popular subject, and that is weather folklore. So we're going to title that one Folklore Brains. Aubrey, that'll be our show.
Love it.
On the 26th. So that's all the shows that are coming up, James, here on WeatherBrains.
Ooh. I wonder how many of us we had that death threat going. Aubrey, you sent out that email.
Yeah.
Some
that was crazy.
Bonehead. Yeah, some knucklehead got on the tweeter and just decided, he said, I've got a gun and I'm going to kill you and I'm going to shoot you. And he roped in looks like about 24 people into this thing. And he attacked others, I think, one-on-one, and then he attacked us as a group. The problem when you attack that group that I was in, I saw some federal accounts on there. And that the FBI didn't like it when you threaten a federal employee with the death threat. But it looks like, Aubrey, whoever this clown is, it's been going on for a while. I don't know who it is, but
that's sad.
Oh,
probably a Russian bot.
Shame. All right, we got to go. WeatherBrains is typically on every Monday night at 9:30 Eastern, 8:30 Central. People watch us at live.bigbrainsmedia.com. If you want to get in touch with us, the email address is email@weatherbrains.com. All of our social media accounts are on that website as well. And if you listen by iTunes, drop a comment. If you love the show, really drop a comment. If you hate the show, it's okay. Drop it too. But on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week and God bless.
All right. Thank you, everybody.
To shoot you guys.
Have a good night.
All right.
All right.
Good night.
We gotta go. Bye. See you guys.